So this object has a mass m of 6 kg given. The force is 70 Newton, and the coefficient of kinetic and static friction are given. The question is, what is the acceleration if theta is 50 degrees? Part B says, what is the acceleration if theta is 40 degrees? So we don't know whether to use the static friction or kinetic friction. If the object is initially at rest, not moving, then we have to decide whether it will start moving or not. In order to decide whether it starts moving or not, we have to find the maximum static friction and also all the forces that are trying to move it against the surface and see which one is bigger. So the first thing you do is to calculate the maximum static friction, and for that, remember that maximum static friction, Fs max, is equal to mu s times normal force. So we need to find normal force, right? In order to find normal force, we need free body diagram. A free body diagram says force is this way at angle theta, and there's an mg here, and there's normal force perpendicular to the surface. That's n. And there's static friction, so this has tendency to move this way. The static friction is the other way. But then, in order to find normal force is in the y direction, so we apply sum of Fy equal to MAY. But we know that if it's going to move, it moves in the x direction, not in the y direction. So AY is 0 anyway. And then sum of Fy means n positive magnitude minus mg minus f sine theta equal to 0. And that gives us normal force. So again, normal force is equal to mg plus f sine theta. So we can calculate that. What is m6 times 9.8 plus 70 times sine of, for part A, theta is 50 degrees, sine 50 degrees. How much is that?
112.4.
And it will be 112.4 Newton. And then we need to find Fs max. Fs max will be mu s times n. Mu s is 0.45. 0.45 times 112.4. How much is that?
50.58.
And then now we need to find what are the forces that are trying to move it this way. N is perpendicular to the surface, not trying to move it. Mg as well. The only force that's trying to move it is Fx. So Fx is magnitude of F times cosine theta. How much is that? So it's 70 times cosine 50 degrees.
45.
Yeah, so Fx is 45 Newton. So you see that Fx is less than Fs max. That's the net force that's trying to move it except the friction itself. It's less than Fs max. Because the force that's trying to move it is less than Fs max, then it means that the block will not move. And therefore, A, acceleration is 0. That's it. All right? So if theta is 50 degrees, for part A, if theta is 50 degrees, the block will not move. What if now we change theta to 40 degrees? Again, we need to find Fs max. Will Fs max be the same if we change theta? What is
Yes.
Fs max is mu times normal force. Is the normal force changing? When you change theta, yes, normal force changes. So Fs max will change, right? But it will change again. We can use the same process. Now, the same 3-by diagram almost. Normal force is different now. If you change the theta to 40 degrees, and mg looks pretty much the same. And this is friction force, and this is x and y. And again, you can write sum of Fy equal to MAy, which is 0. And you write the same thing, you get the same expression for n, but now theta is different. So n is equal to mg plus f sine theta, again. But theta is now different, so n becomes 6 times 9.8 plus 70 sine 40 in this case. So how much is this n?
104.
104. All right, so 104 and Newton, right? And then what is the Fs max? With this normal force, we have a new Fs max. Multiply this by
46.7.
46.7. Thank you. So this is Fs max. Now, what is the x component of F that's trying to move it? Now, what is the x component of F? Fx. Is F times cosine theta again? And is that, how much is that? 70 times cosine 40 degrees. This is part B of the problem.
53.6.
Fx is 53.6 Newton, right? And Fs max is 46. Now we see Fx is bigger than Fx max. So because Fx bigger than Fs max, the block will move. Now, how do we find the acceleration? As soon as the block is moving, the friction, we know that is Fk now, right? So we call it Fk, and now we know the normal force already. Normal force is 104 Newton, and we can write in x direction sum of Fx equal to max. Sum of Fx is Fx, we already calculated, minus Fk, equal to the mass times x component of acceleration. Acceleration will be in this direction, in x direction. So x component is equal to its magnitude. Fk is mu k times normal force. So that is 53.6 Newton minus mu k, which is 0.3, times the normal force, which is 104, equals to m, which is 6, times acceleration. 0.4 equal to 6a, and then a will be
3.73.
3.73 meters per second. So this is how you do a problem if we don't know whether it is moving or not. First, you need to decide whether it will start moving by considering all the forces applying in the horizontal direction or parallel to the surface on the object. If the net force apart from the friction itself is more than the static friction maximum, then it will start moving.
Only in the x direction?
Only in parallel to the surface.
Yeah.
But usually we take that direction as x-axis, so we can save all the x components if that's the x direction. So that's how you treat the problem. All right, let's have another one. Any questions?